Hey everyone, welcome back to the Incredible India podcast series. I'm Sam.
And I'm Taylor.
Today we're doing a deep dive that really might shift your perspective on ancient science. We're looking into the astronomical and mathematical genius of ancient India.
Yeah, specifically focusing on this really profound text called the Surya Siddhanta.
Exactly.
So our mission here is to dig into the sources you've shared, pull out the key nuggets of knowledge, and some, frankly, surprising facts.
Right.
We want to show you how ancient India wasn't just mapping the stars, but calculating time with, well, astonishing precision and really pioneering advanced math that, laid the groundwork for things we use globally today.
So it's like a shortcut for listeners to get informed on this legacy.
That's the goal. A shortcut to understanding this remarkable and often, let's be honest, overlooked heritage.
And central to all this is a figure named Myasura, a sage.
Yes, Myasura. The sources attribute this cosmic wisdom to him.
Okay, so everyone, get ready to maybe rethink some history. This sounds like more than just an old text.
Oh, absolutely. It's got surprising relevance today.
All right, let's start unpacking what the Surya Siddhanta actually is. The sources call it an ancient Indian scientific treatise, a manual of astronomy, but also a pilgrimage site for the curious traveler. Now that's intriguing. How can a science text be a pilgrimage site?
That's a great point, and it really touches on the text's enduring influence. It's this blend of science and tradition,
Okay.
especially around Myasura, the sage it's attributed to. The tradition, the legend, says he got divine instructions directly from Surya,
Surya, the sun god,
the sun god himself, yeah, right at the end of the Satya Yuga.
and the Satya Yuga. That's like a golden age in Hindu cosmology.
Exactly, a period of truth millions of years long. So this origin story makes Myasura more than just a scholar. He's seen as receiving cosmic truths.
Which makes the text itself sacred, in a way.
Precisely. And incredibly, his principles are still used today in rituals, in temple alignments, and maybe most remarkably, in panchangas.
Panchangas. Right, you mentioned those.
Yeah.
What exactly are they? You said millions use them.
Yeah, they're traditional Indian almanacs, calendars, but they're really complex.
More than just dates.
Oh, much more. They calculate auspicious timings, planetary positions, festival dates. They're vital for farming, religious life, daily schedules for millions in India.
And all based on principles from this ancient text.
All derived from the astronomical principles in the Surya Siddhanta. It's a direct living link.
That's incredible. Now, the text itself, ancient Sanskrit, 14 chapters, almost 500 verses. But what stands out is this idea, it blends rigorous observation with poetic logic. How does that work? Science and poetry.
It's quite unique, isn't it? It's not like a dry, modern scientific paper. It uses metrical verse.
Verse, like poetry, why?
Well, it actually makes complex astronomical data easier to remember and transmit orally. Think about passing this knowledge down through generations.
Ah, okay. A practical reason.
Partly practical, yes. But it also reflects a worldview, where cosmic order and art were deeply connected. So it has precise math, real data, but presented in a way that feels more like a profound contemplation of the universe.
A more holistic view.
Exactly. Integrating science with spiritual and cultural life.
Okay, so it's not just old, it's revolutionary in form and content. Which brings us to the really amazing part. The concepts inside.
Right.
Our sources hint these ideas challenge, well, our standard timelines of scientific discovery. What were some of these groundbreaking concepts?
Well, what's really staggering is that the Surya Siddhanta wasn't just watching stars. It was fundamentally reshaping how they understood the physical world.
Like what?
Okay, for instance, centuries before Newton, the treatise describes Earth as round, spherical.
Which was significant back then.
Very. But it goes further. It discusses forces akin to gravity.
Whoa, hang on. Akin to gravity? What did they actually say?
It basically posits that the Earth, by its own nature, pulls things towards it. It describes the Earth as a sphere and says heavy things naturally fall towards its center.
So, not Newton's universal law, but still.
But still an incredibly early grasp of an intrinsic attractive force. Recognizing things fall towards the Earth's center, not just down. It's quite insightful for the era.
That really is revolutionary. How did they even figure that out back then?
It suggests a long tradition of careful observation and logical reasoning, not just guesswork.
Okay, what else?
Well, if that's not enough, get this. The Surya Siddhanta introduces trigonometry explicitly.
Trigonometry.
Yes, the Jaya function makes its debut there. It's a kind of proto-sine function.
A proto-sine, so like the ancestor of the sine function we use.
Exactly. It's essentially a mathematical table of half-chords.
Yeah.
But it did the same job letting them calculate angles and distances with unprecedented power for that time. A really sophisticated tool.
Wow. Okay, gravity, spherical Earth, trigonometry, anything else?
Oh, yes. It deals with truly enormous cycles of time. Vast periods called yugas.
Yugas. You mentioned those earlier. Spanning millions of years.
Millions, yes.
What's the practical point of calculating time on that kind of scale?
Well, these huge cycles gave them a framework, a cosmic calendar, for understanding the cyclical nature of existence.
Okay, a philosophical framework.
Partly, but it also directly influenced practical things, developing detailed calendars, pinpointing solstices, equinoxes. These calculations were incredibly precise.
And these influence life today.
Absolutely. They still influence millions timing for agriculture, festivals, even how temples are built. It connects the cosmic cycles right down to daily human life.
The foresight, the sophistication there is just, well, it's genuinely awe-inspiring. It really makes you reconsider where advanced science began.
Okay, now let's talk about something that might really raise some eyebrows. Trigonometry. We usually hear the father of trigonometry title given to Hipparchus, the Greek astronomer.
That's the common attribution, yes. But our sources argue strongly that Myasura, through the Surya Siddhanta, was the earliest and true pioneer, millennia earlier. That's a massive claim. What's the evidence?
It is a huge claim, but the sources provide specific points. First, the earliest known definition and systematic use of the sine function, the jaya.
The proto-sine again.
Exactly. The Surya Siddhanta doesn't just introduce it, it gives detailed sine tables and how to use them, centuries before Western texts.
So, tables of values.
Detailed tables, yes. And it doesn't stop at Surya. It defines cosine koja, versine kramajaya. It even touches on tangents and seconds.
Wow.
And crucially, it gives instructions for practical uses, calculating sundial shadows, figuring out where the planets are.
So these weren't just abstract ideas, they were tools.
Absolutely. Tools for immediate application, which leads to the next point, spherical trigonometry.
Spherical. So, math on a curved surface.
Precisely. Math for a round Earth, for mapping the heavens, essential for astronomy. Myasura's treatise used this sophisticated math to calculate celestial positions, predict eclipses, map orbits, track those huge time cycles.
With accuracy.
Incredible accuracy. The Greeks tackled similar problems, often geometrically. The Surya Siddhanta used algebra, which was arguably more powerful for this.
So it was a different, maybe more advanced approach.
In many ways, yes. And these methods became foundational. They predate and heavily influenced later Islamic and European astronomy.
It sounds like they really cracked the code for mapping the skies.
They really did, and the accuracy level was remarkable. Those sine tables in the Surya Siddhanta, covering intervals of 3.75 degrees, they were actually more accurate and more comprehensive than tables compiled centuries later by Hipparchus or Ptolemy.
Seriously? More accurate?
Yes. Later Indian astronomers like Aryabhata refined the methods, built on them, but the origin point, the foundation, is right there in Myasura's Surya Siddhanta.
And the practical side, how did this math change everyday life?
Well, these trig calculations were the engine behind the Panchangas, those Indian calendars.
Right, the almanacs.
They allowed for precise predictions of eclipses, solstices, planet movements, things still vital for festivals, farming, even temple architecture alignment today. They used clever methods, like using chords as half angles, and developed really innovative algorithms for planetary positions.
Which gave them unmatched precision for millennia.
Exactly. Unmatched for a very long time.
It's just astounding to think these methods were perfected so long ago and still echo today in math, astronomy, culture. It fundamentally challenges that neat linear progression of science we often assume.
And connecting this to the bigger picture, the influence spread far beyond India.
How sad.
Our sources show it went global. It was translated into Arabic, became known as the Sindhi.
Sindhi.
Yes. And later it was translated from Arabic into Latin. So it became a foundational text in Islamic and then European astronomy during the Middle Ages. It literally shaped how other major civilizations understood the cosmos.
Wow. So it directly seeded knowledge elsewhere.
Directly. And here's something really cool. The etymology of the word sine.
The math term.
The math term itself. It traces directly back to Myasura's work. The Sanskrit word was yaya.
Okay.
That became jiva in Arabic transliteration. Then, through a quirk of translation into Latin, jiva became sinus, which means curve or bay, and that shortened to sine.
No way. So the word sign we use today comes from Ja in the Surya Siddhanta.
Directly. It's a linguistic fossil connecting us right back to this ancient Indian text. Our global math vocabulary literally contains its legacy.
That is an incredible connection. Mind blown. And this accuracy isn't just historical curiosity, right? Sources say modern science confirms it. NASA simulations.
That's right. It's not just ancient history. Modern scientists, using NASA planetary data and simulations, have confirmed the astonishing precision of its astronomical models.
What specifically did they confirm?
Things like its predictions for planetary positions, for eclipses. When you run the numbers using modern computing power, the Surya Siddhanta's calculations hold up remarkably well against contemporary data.
So their methods were fundamentally sound.
Incredibly sound, built on deep observation and sophisticated math, even without telescopes or computers. It shows its timeless relevance. Ancient wisdom isn't always just quaint. Sometimes it's just been forgotten or overlooked.
It's an enduring legacy, then.
Absolutely.
Yeah.
An astromathematical legacy. And its principles are still relevant in calculations today. Plus, within India, it remains a cornerstone. The calendar guiding festivals, farming, daily rituals,
Still relies on it.
still largely guided by its planetary tables, it shows this deep cultural impact. Its science, spirituality, math, devotion, practicality, all fused together.
So if you're listening and thinking, wow, I want to see this, how can you actually experience this heritage in India today? Connect the past and present.
Oh, you absolutely can. And it's quite powerful. There are amazing ancient sites, the Jantar or Mantar observatories, for example.
In Jaipur and Delhi.
That's right, UNESCO say. They perfectly showcase this blend of art and astronomy, built on these ancient principles. They're giant, precise instruments you can see and touch.
Functional instruments, not just monuments.
Still functional, designed to track celestial movements based on texts like the Surya Siddhanta.
Standing there must feel like connecting directly to that knowledge.
It really does.
Okay.
And then you have temples, meticulously aligned with the sun.
Like Konark.
The Konark Sun Temple in Odisha, yes, or the Brihadiswar Temple in Tamil Nadu. Architectural marvels, but also incredible feats of astronomical alignment, embodying these principles in stone.
Wow.
But maybe what's most remarkable is how it lives on at the grassroots level. In rural India, you still find local scholars.
Village calendar maker.
Exactly, Panchanga makers. They still use the Surya Siddhanta's tables and methods passed down generation to generation to calculate eclipses and festival dates, keeping the tradition alive.
So it's not just in dusty books, it's a living practice.
Very much a living, evolving practice.
It's truly eye-opening. Standing in those places, seeing those structures, maybe even meeting someone carrying on this millennial-old scientific tradition.
And if we connect this all back, the Surya Siddhanta isn't just some historical artifact for a museum. It really is a living manuscript.
A living manuscript, I like that.
Yeah, that demonstrates this profound mix of intellect, art, and just wonder about the cosmos. It reminds us, knowledge transcends time, and different cultures found their own paths to scientific truth.
So, wrapping this up, what should we take away? How does this story challenge our ideas about where science really begins? And maybe what other ancient texts out there might hold similar insights, just waiting for a deep dive like ours? What an incredible journey today, unpacking the Surya Siddhanta seriously.
It's fascinating stuff.
From its origins, those revolutionary ideas, spherical Earth, gravity-like forces, and especially trigonometry appearing so early. So many aha moments.
Definitely shifts the perspective.
Yeah, real insights into ancient India's scientific genius. Now, for those of you truly inspired to connect with this legacy firsthand, to experience that blend of science and culture, if you decide to travel to India, we have a recommendation.
Five Senses Tours organizes tours across India, which are immersive cultural experiences. You can email contact@fivesensestours.com. Note 5 is written as a numeral in contact@fivesensestours.com. Or WhatsApp to +919-845-677446.
Thanks everyone for joining us on this incredible deep dive.